Good morning. Today the topic is insulators and types of insulators. Uh, I'm Saritha Kumari, Assistant Professor, EEE Department, working in Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today topic is insulators and types of insulators. So this topic related to map to course outcome 2. This is module 2. So we finished module 1. So this is module 2. It talks about the insulators, mechanical design of the transmission lines. Under that, about the insulators of the transmission lines, and also there is one more factor, mechanical parameter in the transmission lines, that is a sag and tension calculations. So that is a module 2. So accordingly, the course outcome is written as, so discuss about the overhead line insulators, string efficiency. So that is related to insulators only, calculating efficiency. And then, as I said, there is one more concept, sag and tension parameters, okay, which are used in the mechanical design of transmission lines. So that is module 2. So this is a module 2. What are the various topics? The syllabus of module 2, overhead line insulators, first half. So under that, types of insulators, string efficiency and methods for improving string efficiency, and numerical problems based on that. And also in the same context, we see the voltage distribution among those units, calculation of string efficiency. Then following that, grading of the insulators, that is also a continuation. Then testing of insulators. Then the second half of this module 2 or unit 2 is about the sag and tension. So when the transmission line is erected on the supporting towers, uh, there is a parameter, which is a sag, or how much tension the conductor is under, because it is suspended, right, between the two supporting towers. So that is the sag and tension calculations. So how they calculate that, that is about the second half of the module 2. During that calculation, the factors like wind effect, ice effect on that suspended transmission conductors is also considered, and problems based on that. So then at last, last line, you see mechanical design of typical towers and conductors for 400 kV, 200 kV, and 132 kV operations. So now first, introduction, overhead line insulators. So we know that basically transmission lines means to transmit and distribute electrical power, and in general, the components of this overhead transmission lines are, so you can see there are given five. First one, conductors, then there are supporting, so there are supports, right, where the conductor is placed. And then insulators also there, grass arms also there, and some other miscellaneous components, okay, also there. So for understanding, I will show you this diagram, how the components are. So basically you can see there are two diagrams. So you may see the first one, okay, above one, single circuit transmission line, that diagram, or the down one, double circuit transmission line, whatever it may be, the components, okay, the components are same, okay. A transmission line components, basically it consisting of It consisting of conductors. Conductors means this transmission lines, right? Conductors, and then this supporting. These are supports where the conductor is placed. Okay, where the conductor is placed. You can see the next down diagram also the same manner. Conductors are suspended or placed on the supports, right? So that is a second component. And third one, there is a insulator. So insulators, these are the insulators, you can see. Okay, so here you can not see clearly, but the conductor not directly attached to the supporting tower. It is placed on the support using insulator. Okay, so you can see marked clearly, this is the insulator, this is the insulator. Okay, so uh, then cross arms also there. So there are cross arms. So you can see these are the cross arms which supports the insulators. You can see next slides the other diagrams, this cross arms clearly. Okay, of course this is not visible clearly, but okay. So that is the cross arm. Next there are some miscellaneous items. So on the top, okay, something like during lightning, thundering and storm weather conditions, we will face lightning, so which may affect this overhead transmission lines. For example, I'm telling miscellaneous items. Those are the to provide protection against those. They will provide this lightning arresters. Okay, there are some other safety components, safety okay items which comes under the miscellaneous components or items. So you can see once again conductors, first component which is the main component which carries the electrical power from sending end station to receiving end station. So that is a conductor. Then supports means they may be a pole, wooden pole, or tower that may be a steel, or okay, depending upon the okay availability, uh, and keep the conductors at a suitable level above the ground. So that is what supports does. Okay, they keep the conductor at a suitable height, okay, above the ground. Then third one is insulator. Insulators which are attached to the supports, and they insulate the conductor from the ground. Okay, that is the main function of the insulator. Okay, they placed on the support, and this insulator insulate the conductor, okay, from the ground. Means it uh, confine the current. Okay, the conductor carries a current transmission power, so it confine that current only to the conductor. So that means it provide insulation to the conductor. So that is what it means. Okay, and then fourth component, cross arm, which provide support to the insulators. Okay, this cross arm provides support to the insulators. And last one, miscellaneous items. Okay, as I said, the face plates, danger plates, some safety equipment. Okay, so those are like lightning arresters. Okay, anti-climbing wires. All this comes under miscellaneous items. Okay, next, properties of the insulators. Properties of the insulators. So, high mechanical strength. The insulator must have high mechanical strength and high electrical resistance, right? The insulator, whatever it is provided, which insulate the conductor, uh, it must have the basically high mechanical strength, right, to provide the support, okay, to the conductor, suspended conductor. So high mechanical strength first and then high electrical resistance, right? As I said, it confine the current only to the conductor, okay, not allowing to flow to the ground, something like that. So it must have, that means, high electrical resistance, okay. Um and then high relative permittivity, okay. The third point, the third property, high relative permittivity. And fourth one, non-porous, free from impurities, cracks, okay. So it must be non-porous and free from impurities and cracks, otherwise the permittivity will get reduced, okay. So these are the properties an insulator must have. And then, what are the materials? What are the materials used for these insulators? Porcelain. Okay. First, they are telling porcelain. Porcelain. That is a material they use first. Okay, they use the material to prepare the insulators, and then they are telling, but glass. Okay, glass also they use. Okay, steatite and special composition materials. So these are the materials they use for the insulators. Now, second point, how this porcelain is produced. It is produced by firing at high temperature a mixture of coiling, feldspar, and quartz. Okay, so by firing at high temperature, a mixture of these three, a mixture of these three, coiling, feldspar, and quartz. Okay, that is how this porcelain is prepared, and it is stronger mechanically than glass. Okay, so the porcelain, they're telling it is mechanically stronger than glass, and also gives less trouble to from leakage. Okay, it is not easily exposed to the leakage, and also less affected by changes of temperature. Less affected by changes of temperature. These are the what are the benefits, why they use porcelain. So these are the uh, benefits of that material, okay, porcelain material, compared to the other materials like glass, okay. Next, types of insulators. So these types of insulators, there are generally they use first one, pin type insulator, then suspension type, third one, strain or tension type insulator, and fourth one, shackle insulator. First one, pin type insulator. What is this pin type insulator? So, see that, basically look at the first point, that is used for transmission and distribution of electrical power voltages up to 33 kV. Okay, this pin type used insulators, they use up to operating voltages of 33 kV. That is a that is the main point, okay, up to 33 kV. Next, what it consisting of, you can see on the right side how a pin type insulator is, okay, and the down you can see the its physical appearance, okay. So this is how a pin type insulator, okay. So see, on top of it, this is the conductor, okay. On top of it, this the transmission line is passing, and which is insulated by this pin type insulator, and which is placed on the cross arm. So this is a cross arm, okay. Now you can see the clearly how exactly it looks like. You can see on the next beside clearly a pin type insulator is shown, where you can see, now look at the diagram up. There is a groove for the conductor. What they are telling, there is a groove for the conductor on the top. Yes, you can see here also, right? So there is a groove for the conductor to arrange that, and there is a galvanized steel pin, okay. By using that galvanized steel pin, and the conductor is allowed to place in this groove, Okay, and also um, this is prepared like this. Okay, manufactured like this. On top of that, there are sheds or petticoats, and there is a cementing also there. Okay, so on the outer layer is cementing, and there are layers which are called, okay, sheds or petticoats. So this is how the lay outside layer pin type pin type insulator. Okay, this is also another way of showing pin type insulator. So now come to the point once again. So first point already I mentioned, it is it is used up to only 33 kV, and second point, what they are telling is beyond that 33 it become, this type insulator become too bulky and hence uneconomical. Okay, so that is the point. Then second type of insulator, suspension type. So suspension type insulators, you can see on the right side the diagram. So it looks like uh, a long string, like, right? So see how it is there. So its name itself, it says suspension type. So from the top to bottom. Okay, now see that what they're telling, look at the points used for voltages more than 33 kV. Okay, so where it is used, where the voltages are more than 33 operating volt. Next, what it consisting of, a number of porcelain discs. Okay, it consisting of what they are telling, a number of porcelain discs connected in series by metal links. Connected by metal links in the form of a string. In the form of a string. Okay, you can see. Okay, it consisting of number of porcelain discs. Okay, connected in series by metal links in the form of a string. So this is a, okay, you can see on the in the figure also. Okay, this is how the suspension type insulator looks like. Okay, number of discs are there which are connected in series by metal links. Okay, which forms a string. Now here they're telling last point, each disc, okay, or they say unit also, it is designed for voltage of operating voltage of 11 kV. Next, third type of insulator, strain or tension type insulator. So here you can see, uh, uh, so in the name itself it is there. It is used at river crossing corners, shoppers or dead ends. Okay, it is what is the name? Strain or tension type. Means they are telling it is used at river crossings. Okay, and corners where the transmission line is supposed to cross a river. Okay, and where there is a corner for the where the transmission line is. So a dead end of the transmission line. So in those case, they go for this strain type insulator. So you can see on the down, okay, left side diagram. Okay, first better to look at the right side figure where the strain type insulator, see that how it is placed horizontally. Okay, it is placed horizontal, and see it is at the a turning point or where there is a corner. So see it is at the corner point. So that is a strain type insulator. It is placed in a horizontal position, and see, you can see the diagram. To draw the diagram of this type of insulator, this is how it is drawn. Okay, so it is placed on a supporting tower, that is a pole, and it is placed horizontally like this. See, so strain type insulator it is, and through that on which the conductor is passing. Okay, on which the conductor is passing. Okay, now look at the second point. For low voltages means less than 11 kV, Shackle insulators are used as strain insulator. What is this Shackle? That is the last fourth type of insulator. We'll see the next slide. They're telling that for less voltages, operating voltages, okay, less than 11 kV, they use that Shackle as strain type. So Shackle type insulator. So this is the one you can see. In early days, okay, Shackle insulators are used as strain insulators. That's the last slide already. We have seen this point. Okay, for less voltages, so 11 kV, less than 11 kV, they use Shackle insulator as strain insulator. Now, nowadays, this Shackle insulator frequently used for low voltage distribution lines. Okay, for low voltage distribution lines, this one is they're using very frequently, and this insulators used either in horizontal position or vertical position. Okay, they're telling either in horizontal position or vertical position this Shackle insulator maybe, okay, can be used. Okay, and look at the arrangement. You can see, okay, so they can be this point says that only last point, this they can be directly fixed to the pole. They can be directly fixed, this is a pole, right? They can be directly fixed to the pole with a bolt. Okay, so this is how they fixed. Okay, this is a Shackle insulator. Okay, so they can be directly fixed to the pole with a bolt. Okay, or to the cross arm, they may fix it to the cross arm also. So you can see here, this is a bolt, okay, and insulator, this is the insulator, and there is a one more metallic strap, it is D strap they mentioned. Okay, and okay, this is a Shackle insulator. Okay, I hope you understand. This is how it is fixed to the pole directly, okay, using a bolt. Okay, so and this is how for understanding a Shackle insulator looks like. A Shackle insulator looks like. So these are my references. So the figures, the points I have taken from book 2. Okay, BK method. Okay, method. Title is Principles of Power System. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.